Okay, we have a triangle plotted up here, and we have a rule for transforming that triangle. Remember, a transformation is just a function rule. I input points and I output new points. Input, output. It's just a function rule, and it can do a variety of things. It can translate. It can slide a shape over. It can rotate. It can turn a shape. It can reflect. It can flip a shape. It could do some combination of those things, a slide and flip, a turn and slide, all sorts of things. It can make the shape larger, shrink it down smaller, or it can even distort it. It can stretch it sideways or stretch it up, right? So it can do all sorts of different things. So all it is just I input points, I output new points. That's all. And we want to look at what each individual transformation does, and I'll see what happens. So here's a particular rule. This is like, if you remember in algebra, you may have run across something that looked like f of x, right? And that means the f is the name of the function. And here we've got, I think this is some sort of Greek letter. I should look this up, and I didn't. Anyways, and it's of xy. So it's just a function where I plug in two things, two numbers, and those are coordinates. And I'm going to output new coordinates. And this is a rule for what we're doing with the new coordinates. And what it says to do is, I take my original y coordinate, I add 3, and that's my new x coordinate. And I take my original x coordinate, I subtract 3, and that's my new y coordinate. So I'm taking the coordinates and I'm like doing a little, adding and subtracting, and then I'm flipping the positions. Okay. So let's see what happens. Now when I'm doing a rule like this, and by the way, here's the 3 coordinates for our 3 pairs of coordinates for our triangle up here. When I'm doing a rule like this, it helps me to do one coordinate at a time for each point. So I'm doing the same operation 3 times in a row. So it says to take the y coordinate, add 3, and we get our new x coordinate. So I take 2 plus 3 is 5, and that becomes our new x coordinate. 2 plus 3 is 5, that's our new x coordinate. 4 plus 3 is 7, that's our new x coordinate. Now we'll do our y coordinates. Take our original x and subtract 3. So 1 minus 3 is negative 2. 3 minus 3 is 0. Close one. 4 minus 3 is 1. Then we'll go plot these points and see what it looks like. So we have 5, negative 2. So let's see, we have 1, 2, 3, 4, 5, and down 2. Then we have 5, 0. And by the way, let's mark this as A prime, so we keep track of. That's where the point A ended up. Point B ended up at 5, 0. 1, 2, 3, 4, 5, 0. So that's B prime. And then C ended up at 7, 1. So 5, 6, 7, up 1. And this is C prime. Here's our triangle. And there, I'm going to write B prime over here. Okay. So there's our whole triangle, there's our new triangle. And we're told that it's a reflection. Where's the line of reflection? Well, to find the line of reflection, you just kind of look at, you see, from B to B prime, the halfway point is right there. From A to A prime, the halfway point's right here. And from C to C prime, the halfway point is right there. And the halfway points are all on that line of reflection, right? Because each point gets reflected across the line of reflection so that it lands as far on the other side as it is currently on this side. So each point and its reflected image are equidistant from the line of reflection. So our line of reflection passes through here. Okay, so let's take a ruler and draw kind of a nice looking line there, best I can. There's our line of reflection, which is y equals x. So because the slope is 1, y equals x, and it's 1, 2, 3, minus 3. Okay. All right. There we go. Was there any other questions about that? Oh, well, notice how we're going counterclockwise in our naming, ABC, but when we come across the other way, it changes to clockwise. So reflecting, like left hand, right hand, just kind of changes changes the way they're named. Changes clockwise to counterclockwise. And that's it. There you go.